Talk about compensating for a current or wind, and this is going to involve, you guessed it, subtracting vectors. So what happens is we have a desired course. So we want to be going 25 knots at 135 degrees heading. So this is our desired course, desired, D-E-S. But we have a current, and it's going to blow us off course. So what do? We compensate. How? By steering into it somewhat. So the current's going to be kind of blowing like this. More or less. And that means that we would want to then actually have, so we have our current here, right? And let's go ahead and move our desired over here because it's going to get in the way otherwise. What we're going to then have to do is steer into this, and this is going to be what's called a corrected course. So this is the course that if we actually do this, right, then the effect of the current will cause us to end up where we want to be. In other words, we're compensating for the current or the wind. So, that being said, here's how we go about it. These numbers should look familiar. They're the same from the last one. We know that this is really a 315 degree direction. 450 minus, sorry, D for direction, there we go. And that this is a really 15 degrees direction. You must make sure you convert to direction because then you can figure out the components. 25 cosine 315 and 25 sine 315 and 3 cosine 15 and 3 sine 15. The big difference is because we're subtracting the vectors, we have to then subtract the components, which is a pretty straightforward operation. All we do is do the opposite of what we did before. Remember, because we're using direction and everything like this, all the different numbers will take care of themselves. And I encourage you to put these into the calculator all at once. It's going to be more accurate. So I got a positive 14.779. And when I subtracted the y components, I got a negative 18.454. This is a good part of our answer, but it's not the whole one. So what we need to do is, and I strongly recommend this, is you actually plot it. So we're going to plot the 14.4 and the negative 18.4. So this is our negative 18 and change, and this is our 14.779 if you want to get technical. 454. That means we can use the Pythagorean theorem to figure out the magnitude, and that would mean we're going to take the whole 14.779, square it, plus, I'm going to run out of room, square it, and then take the square root of the whole mess. So when you do that, you get the magnitude, or 14.779 squared plus 18.454 squared. So that is 23.642. And because this is our magnitude, that's going to be in knots again. How do I know that? Because I was given knots as the magnitudes, so I end up with knots again, nice and consistent. I'm still, just like we did last time, going to take the tangent inverse. Now, you may be asking yourself, the theta, that is the angle inside that triangle, is going to be the tangent inverse. Always? Yes, always. Is it always going to be the y over the x? Yes, it is. So it's going to be the tangent inverse of the 18. Now, I would recommend treating them as positive, though. That's something makes life a little bit easier. But that means then the 18, the opposite, 0.454 over the 14.779. In whole numbers, whole degrees, right? We end up with the tangent inverse which is 51.3 or 51 degrees. And just like the last time, we want heading. So this is 0 degrees heading, 90 degrees heading. We just figured out this angle right here was 51. So that would mean 90 plus 51 is 141 degrees. Is it important to put the H? Why, yes, it is. So we know it's a heading. Notice, we started with heading, we ended with heading. This is the course, the corrected course. That is the course we're going to steer to compensate for the current, in this case current, or the wind if that happened to be the case. So notice how this is a different velocity, different speed. Now we're going about 24 knots instead of 25 because the current is helping us out. And we're steering certainly in a different thing because it's pushing us in a different direction. And that, as they say, is that.